So let us jump in this first video to talk about routing. So we're going to set our foot in this concept so that we can better understand what we're talking about here. And we're going to answer a couple of questions like what is routing? What is a router? What is a route? And then we'll end up by talking about the static route, which is one of the mechanisms that we have in the routing concept. So, what is routing? Imagine that we have a couple of networks with devices within, like servers, desktops, laptops, access points. You can name them all. And we want these devices to be able to talk to each other. That is, devices from one network needs to talk to devices on the other network. So we need a mechanism that can permit this traffic. That mechanism is what we call the routing. In other words, routing is the process of selecting a path for traffic between or across multiple networks. Because you may want to make sure that if you have a device that is in one network that needs to talk to a device that is in another network, in the second network, you send that traffic to that network instead of the wrong one. So this is what we call the routing. Let us take an example. Suppose we have four networks, right? Network 1, network 2, network 3, and network 4. And this is like cities. So we're going to have our neighborhood. So we're going to have to create a mechanism that can permit, devices, for example, in network 2 to go to network 3 because they will not jump. They need a mechanism to go there. That's why we will build this infrastructure between those networks that is going to permit traffic from one network to go to the other one, depending on the need. For instance, you see in this screen, you see on this picture, the blue car that leaves network 4 is going to network 1. And you see there is a path that has been built to go to network 1. But for the green car that leaves the same network, network 4, there is a different path that is going to use to go to network 3 instead. And you have the other car that is orange that leaves network 3 because it wants to reach a device on network 4. It's going to go to network 4 using a specific path. So it's this mechanism that exists in our regular life that we call the routing. And the device, all the devices are going to pass through the roundabout that we can call a router. As you can see, all these streets, the road leaving network 4 is going to meet the road leaving network 3 or leading to network 3 at the same roundabout. And that's where we have the circle that can be used for traffic to go here and there. That's exactly what routing is. Now, this roundabout that we saw there is the router, which is then the device that is going to permit this path to be built. So all the networks are going to be connected to that device so that a packet that leaves one network can flow and go to the other one, as we saw on the picture from the previous slide. And we have many kind of routers because we have many manufacturers that builds them. So a router is going to be like the representation of each network. That's what we call a gateway. So that data can pass between networks that are connected to that router. And as you can see, Cisco has, for example, the ISR 1000 or even the industrial catalysts that are also doing the same job. But we have other manufacturers building, devices that do exactly these mechanism, that put in place this mechanism using what we call the route. So a route is the path that has then been built, predetermined or learned, so that a packet that leaves a network that reaches a router can find its way out. It's an entry in the database of the router that is going to permit packet to be forwarded to their destination. And this entry can be statically configured by the network engineer, you, or it can be learned dynamically from other routers. Now, talking about a route, it's an entry, and that entry, let us talk about it. First of all, we said it can be statically configured or dynamically learned. But most importantly, we need to understand that a route is made of the destination. Because when you take a route, you should know where you want to go to. And the destination is the network where we want to go. And that network needs to have a network mask. And for that, we need to know who do we send the packet to. The router needs to know to who the packet has to be sent. That's what we call the next hop. And the metric is the believability of the route. Is that route the best one, the best way to get there? That's the metric. And the smallest it is, the best the route is. And you see an example here to set up a route. We say IP route. We put the network like 192.168.19.0. We put the network mask, that is 255.255.255.0. And we give the next hop. That means for packet destined to this network, send them to the device that has the IP address 172.19.23.2. And we give the believability of 7 to that route. That means if we have a route that has a metric of 1, it's going to be preferred. And in the routing table, the first parameter is going to indicate whether the route is statically configured or learned dynamically. Because we're going to see in the other videos how we can use protocol to learn route dynamically. And the next hops are the neighbors of the router. So when you are on a route in a router, you are going to set the routes, and you should handle the packets to the neighbor that knows how to reach the destination. Let us take an example here. Let us suppose that we have, of course, before getting to an example, we have also the elements that we're explaining about the believability of the route. And then we have the pros and the cons of the router. But the most important thing to know here is that the static route is not processed. The one that is set by the network administrator is there. It's not going to change. But it's not scalable, because in order to set up static routings, you must know all the network, and you must manually set this up, which can be tedious when we have multiple networks. Let us take an example, as I was saying. In this design, we have 3 routers: router 1, router 2, and router 3. And we can set up static routes to be able to reach the network 192.168.56.0 from router 1. This is how we're going to do. So this is the configuration that we can put in place to permit the flow in this network. In router 1, for example, we'll say IP route 192.168.56.0 on the mask 255.255.255.0. The next hop is router 2, and the IP address of that interface is 192.168.10.2. And of course, it's directly connected to router 1, as you see on the diagram. Since router 1 knows how to reach router 2, is going to handle him all the packets destined to the network 192.168.56.0, because router 2 knows how to reach that network. And obviously, you can see we have two routes going to 0.0.0.0 with the mask 0.0.0.0. That's what we call the default route. And for example, for routes going to internet, because we cannot know all the IP addresses that are on internet, we will tell the router for everything else, send there. And for router 1, we have one path through router 3, right? The IP address being 192.168.10.6. And the other path is through router 2. That's why we gave a metric of 3 to router 2, because we want the default router that sends the default traffic to be router 3. So these are elements that we set when we do the static routing. In the next videos, we'll talk about dynamic routing, and I hope you have enjoyed this video. If you enjoyed it, leave us a comment. You can subscribe to the channel so that you can have all the other videos, and let us know if you have any question. Until then, see you in the next video. Bye.